Welcome to MyProjectBazaar.com. Our project title is Majority-Based Test Access Mechanism for Parallel Testing of Multiple Identical Cores. Abstract. The increased use of multi-core chips diminishes per core complexity and also demands parallel design and test technologies, and especially important evaluation of the multi-core chip has been the use of multiple identical cores, providing a homogeneous system with various merits. This paper introduces a novel test access mechanism TAM for parallel testing of multiple identical cores and identifying faulty cores to derate the chip by excluding it. Instead of typical test response data from the cores, the test output data used in this paper are the majority values, that is, the typical test responses from the cores. All the cores can thereby be tested in parallel, and the test cost are exactly the same as for a single core. The proposed TAM can be implemented with on-chip comparators and majority analyzer. The experimental results in this paper shows that the proposed TAM can test multiple cores with minimal test pins and test time and with hardware overhead of less than 0.1%. Let us see the flow of our project. First, in our project we have to implement two phases. First one is test control function and second one is room memory architecture. In test control function we have to implement automatic test generation pattern, that is, we doesn't give any input pattern, so automatic test generation pattern is generated using the LFSR function. And multi-core architectures. In this architecture we have to implement adder design, comparator design, subtractor design and multiplier design. From that output we have to given into the test output result function, and also we implement majority design functioning process. Then we have to compare this signature with the ROM architecture golden signature, that is, we have to store the output of our designing architecture in the ROM memory. So in that ROM memory it produced golden signature, and in our architecture, that is, adder, comparator, subtractor and multiple results are stored in signature. So we have to compare it using output response comparator, and we have to identify that fault detecting process and fault status level, and the performance evaluation is done. Performance evaluation we have to calculate the power, area and the time of the designing process. Let us see the output of our project. When we finishing this designing process, then we go for the simulation radio button and click this simulate behavioral model. It produces our output window. Now our process is running in simulation elaboration. Now it will produce our output window. This is our output window, and we have to set clock, and we already set the clock in this process. We only set this reset button. When we click on this but reset as 1, it will be reset. Then click on this to 0, it will produce our output, that is R1111, that is output is 1111. It will produce the hyphen symbol, that is nothing will happen in this process. So now MUL means our process 0010 means it will produce our multiplication output result. If we give clock so much of time, it will produce the output related to that project. See, it produce COM process for comparator and MUL for multiplication. So this hyphen for nothing happen. So this this is our clock overall process file. Then for power estimation we have to run our for calculating the performance of our project we have to click on this implementation radio button. In that, click on this synthesis XSD. This synthesis XSD produce our simulation file, that is simulation details. Then click design summary, and then this is our RTL technological diagram. In that we have to create that adder and our row memory functions. All are there in this file. This is our RTL diagram.